All right, so we're going to do a correction to the slant asymptotes. I had made a mistake in my recorded lecture, and so I have removed the part on slant asymptotes, and I'm just going to repeat it here. So the slant asymptote comes when if we have a division, if we have some function of x, and we're going to have the quotient plus the remainder over the divisor. So I guess for quotient, let's just call the quotient, we'll call these words. We'll have some quotient plus remainder over the divisor. If the quotient is linear, the line is the slant asymptote. And so we wanted to look at the first function that we had. Let me do this in purple again. We had x cubed minus 2x squared plus 1 over x squared minus 3x plus 2. And so we want to find the slant asymptote. So we need to do the long division and get the quotient and the remainder. Now for this to work, or for what we're going to see coming out of this, for getting a slant asymptote of our graph here, the quotient is going to need to take the form of linear. If it has a value, if the quotient comes out just being, so if the quotient ends up being a number, then it's a horizontal asymptote. But if the quotient has the form mx plus b, then it's a slant. So let's do this long division here and see what happens. So I'm going to write this in descending powers of x, making sure to keep space for my x to the first term. And I'm going to divide it by x squared minus 3x plus 2. So x squared goes into x cubed x times. And so x times x squared is x cubed minus 3x squared plus 2x. I'm going to change my signs. And I'm going to add. These cancel. That gives me a positive x squared minus 2x plus 1. Let me put this up here. And x squared goes into that one time. And so I get x squared minus 3x plus 2. I'm going to change my signs. And add. These cancel. I get x minus 1. So this is my remainder, but this part here is my quotient. And notice my quotient is linear. So my slant asymptote is going to follow this line. Well, let's look at our graph of this here. So I have x cubed minus 2x squared plus 1 divided by x squared minus 3x plus 2, which is the red lines. But I'm going to change it to blue because I really can't stand the color red. The asymptote I found, y equals x plus 1, is the slanted line that these approach. And so we have found the slant asymptote.